And here we go with example 4, normal distributions, example 4, part B. Again, we were told that life expectancies in the United States are normally distributed, therefore the bell curve with a mean of 78 years and a standard deviation of 7.2. We want to find the probability that a randomly selected person will live to be between 59 and 65 years old. So again, both of those are below the mean. 59 would be down here, and 65 somewhere here. It's not that important that you have the scale right in terms of the distance between them, just the fact that they're both below the mean. And if we want to know between, that would be, to me, the picture of the shaded area. So again, the original setup would be to find the probability that 59 is less than x, x again being our generic variable here, and then 65 on the other end. X is between 59 and 65. So a probability statement and a bell curve picture. Once again, we're not able to use our table until we standardize both of those ages. And so again, here would be our translator that changes values of x into z-scores, as we did before spring break. So again, I'm a visual person, as you know. It helps us reason out what to do with these particular numbers. But again, we have two z-scores that are below the mean. My prediction is both of these will come out to be negative when we crunch them out here momentarily. So again, the same looking picture, but a standard normal, a bell curve with 0 in the middle. So let's change that x into a z, and let's standardize both of those ages using this. So on the 59, that would be 59 minus the mean of 78, divided by the standard deviation of 7.2. And again, I'll remind you to round these to 2 decimal places, because again, the table we're using goes out to 2 decimal places. And that crunches out to negative 2.64. All right, I did that in my head, right? Okay. And then on the 65, same thing. We take 65, subtract the mean of 78, and divide by the standard deviation of 7.2. And off the top of my head, that crunches out to negative 1.81. Once again, when you round it to 2 decimal places. I want to remind you that is how many standard deviations these particular ages fall below the mean. And notice, they're both negative. If you're below the mean, you're going to have a negative z-score. Now it's basically, yeah, you know, we might as well do it at least one time here. So once we have that standardized picture there, of course, and I want you to all join me here, all right? So table time. Anyway, so of course we want to look up those 2 z-scores here on the table, and it doesn't matter which one we do first. Here's 2.64. All right, 2.64 generates a middle sliver region of 0.4959. So 0.4959 would be that area from here to the middle. Remember, this table always gives you that middle sliver, as I keep calling it. So that would be that region. And then 1.81. I realize that the z-score is negative. The areas on the top side are the same as on the bottom. So 1.81, 1.81 gives us a middle sliver of 0.4649, 0.4649. Old man better remember that. 0.4649. Picture got a little bit messy there, sorry for that, but I hope you would agree that we'd want to take this middle sliver and subtract this middle sliver to leave the region that we're looking for. So it's a matter of subtracting them now. I'm a little bit nervous now because I'm probably going to subtract wrong, and this will be on the internet forever for people to make fun of me. 0.0310, and that works for me. If you want to change it into a percentage, that'd be 3.10% of our population lives to be between those 2 ages. So there you go. I'm a little nervous about my arithmetic. I believe that's right. So that would be part B, all right?